Hello, everyone, and welcome to this Axelar Learn session. My name is Jackie, and today I'm joined with Jeremy from Moonbeam. Jeremy, how are you?
I'm doing great. How are you?
Great, thanks for coming. Today we'll be covering how to design multi-chain dApps. We'll look at examples of the front-end and user experience, look at the back-end infrastructure and archetype design, and we'll kind of compare how that differs from traditional Web3 dApps that might be built for like a single chain use case and with that in mind. So first of all, to start off, I'm going to walk through a brief overview of the Axelar technology stack so we kind of understand how Axelar fits into this and how the cross-chain messages are passed. First of all, at the very top, we have the various chains that Axelar connects, as well as the applications built on top of them, right? So EVM chains like Ethereum and Avalanche, Cosmos-based chains, Polkadot chains, um, Moonbeam, of course, as well as all the dApps that live on them, be it games, DeFi, governance, so forth. These chains are connected by Axelar through a series of gateways that are deployed to them. This could be a smart contract, it could be other logic, but these gateways help route and pass along logic, messages, requests, and execution from Axelar. When users request cross-chain activity on these gateways, the gateways pick it up and then broadcast the event to Axelar. This is known as a cross-chain gateway protocol. It's chain agnostic, meaning it doesn't take into account what type of chain it is and is able to translate, delivery, route, and finalize the cross-chain message requests. The message finalization is done by Axelar's decentralized validator set. These validators vote to verify events happening on these external chains by consulting their own nodes that they're running and use multi-party computation and cryptography to come to a consensus on the status. So with that out of the way, and with a quick overview of how Axelar works, let's take a look at what a typical Web3 dApp user experience looks like, one that is not a cross-chain dApp. Jeremy, would you like to walk through each of these steps and kind of talk about what's going on here?
Sure. So this is a simple graph of how the user experience will be in a typical single chain app. If you've ever used one, you know that the user will have to connect to the site with their wallet, which is probably MetaMask. This is either automatic, like when you open up the site, it'll prompt you immediately, or it's what happens when you press a button in the top right corner, which if you're going from Web 2 to Web 3, it replaces the login that the traditional Web 2 login. And once you're connected to the site, the network that your wallet is connected to will either be the one correct network or some other network. If it's the wrong one, then the front end should ask you to switch to that network. Or if you're using MetaMask in particular, they have the option to prompt the user to add that network to the MetaMask wallet. After that, the front end can present a transaction to the user. This is usually when they provide some input, such as pressing a swap button. Um, and this transaction can be signed and sent using that MetaMask wallet. And that can be sent off to an RPC node. And once that propagates to the network and a block is produced, the transaction is fulfilled. And during that time, the front end should update and let the user know what their transaction, what the status of their transaction is, if it's success, if it's a failure. And it usually notifies them with a little toast notification. And if you're not familiar with that terminology, it's a little rectangle that pops up in the top right or bottom left corner that isn't too intrusive. And it's just to let the user know what happened with their transaction. But a multi-chain front end, on the other hand, will be not too different, but it has a couple other steps.
Right. So if we considered like just a typical dApp living on Ethereum, for example, when you first join, of course, MetaMask would default connect to Ethereum. And if it lives on Moonbeam, for example, you can switch the network once. But typically afterwards, after you get the wallet set up, it's kind of like a straightforward, like you've done your setup part, and then you just do any transactions. Maybe you're sending, maybe you're swapping, whatever it is. You have the wallet approved, but it's kind of like living within that environment, right? And when
Yeah.
building cross-chain, you have to think of things slightly differently. We have a question from Osani David about asking about what about the security of this project? We've been seeing lots of exploits. So this Axelar Learn session will focus mostly on like how to build cross-chain dApps. If you want to learn about security of Axelar, we have plenty of other videos and tutorials and blog posts that you can check out on our YouTube and on our website. Okay, so let's quickly then look through what a multi-chain dApp experience might look like.
Right.
Jeremy, would you like to talk through this?
Absolutely. So, as I mentioned, a multi-chain dApp wouldn't be too much different, except since it's multi-chain, there's a lot more variables to manage at every step. So, users can connect to multiple networks, there are multiple transactions, and there are multiple contracts. So, let's break it down a little bit. First, a user will connect to your front end, just like normal, in a normal single chain dApp, but they could be on one of many networks. So instead of expecting and checking for one network, the front end will have to check against a collection of networks. And in this case, when you're designing your front end, the switching between networks is going to be a lot more important than if you were just a single chain dApp, because you could, if you were on a single chain dApp, just rely on MetaMask or whatever wallet that you're using or that you're expecting to switch for you, to prompt the user to switch for you. But since there's functionality on multiple chains with a multi-chain dApp, you will want to create a drop-down to switch between the different chains that have functionality, or maybe a radio component, but drop-down is what most people use. Maybe one day GMP protocols like Axelar will support every single chain out there, and that can be obfuscated away. But for now, we need a dropdown.
Yeah, a quick
Do you have a
question
question?
here from Mooncop is asking, what if there are different wallets that are required and different contracting runtimes? How would this look like for Cosmos wallets and Near wallets and, a cross-chain dApp that supports both, for example?
Yeah, so there are going to be different protocols that support GMP differently. So I don't think Axelar supports Near yet. Is
No,
that the case, Jackie?
that's right. So Axel right now supports Aurora, which is an EVM implementation of Near, because we support a lot of other EVM chains as well, and there's fundamental similarities between them, which makes it easier to onboard. So um, at the cross-chain protocol level, it depends on what the protocol supports. For example, on Axelar, it would be Node and Near, but yes to Aurora. But in terms of a dApp that's building cross-chain on like a front-end user experience level, all you have to do is swap the wallet connection and using the wallet API, right? So uh, it's
It
just
will,
adding another network.
yeah, it's like adding another network, but it'll be more difficult, of course, because you're going to have to adhere to the rules of Near or Algorand or Cosmos, and you're going to have to adapt them into your entire system. And so there's probably, if you plan on working on those environments, there's going to be a demand for adapters out there. So that's up to you to develop, and it'll be very helpful if you do. Okay, so moving on. So next, a transaction can be signed once you are, or presented to the user once you're connected to a network, and just like in a typical dApp, that transaction can be signed and sent to a node. The difference here is that instead of updating the front end for only this origin chain transaction, there are going to be at least two chains that you're going to have to track. Uh, but if you're working on Axelar as your GMP provider, you're going to have three, because there is both the origin chain, the Axelar chain, and the destination chain. And this is probably the most difficult part of or the most difficult aspect in comparison to a single chain deployment, because this isn't as easy as a simple dictionary of of uh, of items that you can switch between based off of your dropdown. There's going to be different protocols that you're going to have to, and different SDKs that you're going to have to use to get all of this data. But speaking of SDKs, since we're all using Axelar here, you'll be able to track the progress through the connected contract system via the Axelar SDK. So you're going to be able to track the origin chain transaction using normal Ethers.js, but then afterwards you're going to take the data from Ethers.js and use the Axelar SDK to figure out what the progress is for the rest of your transactions. And you're going to be able to display that data to your user. But you may opt to display that data to your user differently from what you would in a single chain dApp. Of course, it's up to you, but in my opinion, having 3 toast notifications, maybe 30 seconds between each other, isn't a very good way of displaying the progress of your transaction, because typically when a user sees a toast notification, they think, okay, that one thing is over. But you're going to want to connect these 3 transactions together. So you could use a card or just simply display the data or the status of these transactions together just on the screen. And if you've ever used a bridging UI, it'd be similar. But that should be it after all of your transactions are through, after you're done with your all 3 transactions. And we can take a look at the example front end now, if you'd
Right.
like.
So yeah, I'm just going to quickly kind of summarize some of the stuff you said there, Jeremy. So essentially, there's 2 aspects that's different in a cross-chain design dApp, rather than like a dApp designed for a single chain, right? One is the adding and switching of networks. 2 is the tracking of the transaction as it flows through the multiple chains, right? Tracking the networks is the more straightforward one. You have like a list of supported networks, and as the user switches between them, the wallet needs to like switch accordingly. And then the tracking the transaction is the slightly more difficult aspect of building multi-chain dApps, where typically you just need to track like a single Ethereum transaction. Once it's confirmed in a single chain dApp, you're done, right? But in a multi-chain world, you need to track, for example, maybe a deposit on Ethereum, and then the status of the Axelar as it processes this multi-chain transaction, and then the status of the transfer being completed on Moonbeam. And so there's like a lot of different steps and status updates that go in there, and all of this should be continuously deployed in a friendly way to the user, that makes it easy for them to track and follow along with how their transaction is going.
Absolutely.
Okay, Jeremy, would you like to walk through like an example demo of a front end built using this structure? I'll stop screen share and let you present.
Sure.
Let me just, yeah, there we go.
Okay. All right. So this here is a example front end that I made. It's not too pretty, but it gets the job done. We can connect to the MetaMask wallet up in the top right, and we can select which network we want to connect to. So, for example, if we want to connect to the Phantom testnet, we could switch the network, and it would prompt everything to change. But I guess let's start with Moonbeam because they have the most testnet tokens there. I don't want to use up Phantom because I only have a little bit left. Although there is a faucet, it's a testnet. So let's use some input. So I can say something like Jackie is awesome. Great.
Thank you.
Yeah. And we could select our destination chain. So these are connected contracts. We're using a GMP protocol. So we're sending it from Moonbase Alpha to say the Phantom testnet. And since this is a peer-to-peer smart contract design, the data is decentralized. So the data from Moonbase Alpha will be sent and then stored on the Phantom testnet contract. So let's submit that transaction, and we should be seeing MetaMask pop up. And here we're going to be paying a little bit of our currency, our native currency, for gas and fees. And that should be that should start going through. So uh, in the backend, or not the backend, but in the code of the front end, what it did was use the basically it used ethers.js to send a transaction, and we were able to monitor the transaction using that package. And it gave us a transaction, and we're able to display the status of that transaction. And Axelar will take the hash, or the transaction hash, and use that to track the transaction as well. So that's why these two are the same. As we can see, the Moonbase alpha status was a success, and we'll see the Axelar status as pending. And if we take this and look into Axelar scan, we should be able to see the status. Axelar scan is a lot more pretty, and you'll be able to see the status here in a lot more detail, which the Axelar SDK provides a lot of that detail as well. So if you wanted to, you could provide all that information to the user, but I prefer to just have just pending here, because that's, you're not expected to put an entire Explorer into your front end when you design it.
Right.
This might take a little while, so if there are any questions, now would be the best time to ask.
Yeah, let's see if there's any questions or comments. So earlier on, you were playing with the from network, and behind the scenes within the front-end user experience, there's code switching the network, switching the wallet network automatically. If there was a network that, for example, you haven't added to your MetaMask yet, it would prompt you to, add that when you selected it. Jeremy, of course, has all those added because he's been playing with this a lot.
Yeah.
So that's kind of the aspect one, right? The network switching. And aspect two we're seeing right now, which is tracking the status, right? It doesn't need to be as pretty as Axelar Scanner with all the information that it has, but enough to give your users an idea of what's going on. And so this does depend a bit on the protocol, cross-chain interoperability protocol you're using. And with Axelar, you can use the SDK to collect the information you need to display to the user.
Absolutely, and that's one of the best things about Axelar. You get to see the status as it's happening. And there we go. Success and success. Well, the Phantom testnet is a lot faster, but let's see if we can read that data. There we go. I guess it's true. Jackie is awesome.
Well, if it's net cross-chain, it must be true.
Yeah, exactly. um, so this is just an example, a very very simple example of sending data across this GMP protocol. If you want, we can take a look at the code later, but I think we can also look at some examples of how to design cross-chain applications.
Yeah, so Jeremy, thank you for walking through that demo. Let me get the slides back up here, and then we'll continue uh, with the discussion. So far we've kind of been talking about like building the front end aspect, the user experience aspect of these dApps, right? How to select wallets for your users, how to show them what's going on with their dApp, so they're not sitting there for 2-3 minutes wondering if things went through. Next, let's kind of talk about the fundamental backend structure. Architecture design that kind of goes along in building a cross-chain dApp, right? So it's a bit different from single-chain dApps, and there's two typical models that gets used. One is the peer-to-peer model, and the other is the hub and spoke, or sometimes called home base and satellite model. So um, essentially, this kind of backend design talks about how the dApp is able to be deployed to multiple chains and kind of the logic involved on each chain, right? Um, in a peer-to-peer model, the contract logic is fairly duplicated and similar and identical among all the supported chains, and each can kind of pass and route messages to each other. Um, Jeremy, anything you want to add here?
Yeah. So coming from a front end perspective, it'll be very easy to implement transactions and reading and just generally repeat the same code for this peer-to-peer architecture, because you can just take an array or a collection of the contract addresses, and essentially, since they have very similar, or they typically have very similar contracts, you can just read and do the transactions uh, that are very similar and just switch between them. But the hub and spoke might be a little bit different.
Right. And in a hub and spoke model, typically you have one chain called like the home base chain or the hub chain that has the majority of the logic, and it can also act like an overview chain that kind of uh, needs to be reported back to if the other chains are, doing status updates and sending messages and so forth. Would you like to talk briefly through some of this, Jeremy?
Yeah. So if you're doing a hub and spoke model, which might be easier on the smart contract side, if in the long run, because you don't have to have a decentralized logic system. Um, Here, what you're doing is you have a contract on one chain or on multiple chains, and that sends some data to uh, some home chain logic smart contract. So if you're deploying on Moonbeam, for example, you would be sending data from Phantom to Moonbeam. It would be doing the logic on the Moonbeam side, and the data would potentially be stored on the Moonbeam side. So if all the data is stored in one chain, that would make reading especially easier because you wouldn't have to switch your reads between chains. Um, if but if you're doing a transaction, it might be different because the logic might be different on the satellite chains than on the home base chain. So at the end of the day, you're going to want to have a similar experience for your users, regardless of uh, which architecture you choose. But you just be aware that the implementation could be significantly different.
Right. And I think one of the advantages possibly of the hub and spoke or home base and satellite model is it kind of allows for slightly more complex like dApp logic because most of the heavy lifting work is being processed on a home base chain. It's
Mhm.
like more similar to like a single chain model where um, whereas in the peer-to-peer, right, you need to, as Garrett mentioned, you need to kind of find a way to have it decentralized um, in a manner approve the different transactions that are being sent without kind of like a central chain and like being able to like look at everything and see a holistic view, right? Everything's happening permissionlessly, and you need to be able to approve um, kind of what's going on between the chains. So, that's kind of an overview of the backend. And so today we've covered kind of the user experience aspects of building cross-chain dApps, as well as the backend architecture and design aspects that goes into designing these. We went through a demo of an example dApp that Jeremy has built, cross-chain dApp, to kind of showcase all of this. And by the way, that dApp, I believe, is a peer-to-peer structure. There was no home base chain, right? Between all the different possible chains selected, the same logic is deployed. And so hopefully this was a helpful session and can give you some insights into building your own dApps that are, you know, inherently cross-chain focused, right? From the get-go, it's designed with cross-chain in mind. Jeremy, anything you want to add as closing remarks?
No, other than if you want to take a look at the code of the repository, I do have a link, which can be shared on the appropriate channels very shortly
Yeah, perfect, Jeremy. If you send the link
to
over,
the thread.
we'll post it with a YouTube in the description. I'll post it right now. Perfect.
Uh-oh.
Looks like Jackie dropped off.
So, yeah, someone pressed the wrong button, maybe. Oh,
uh, Jeremy, thanks a lot. This is really helpful. And for those of you who are looking for that link that Jeremy was mentioning, it is on the screen here and posted in the comments on the YouTube video, which will be available at youtube.com/c/axelar core.
yeah. And if you have any questions, you can always ask the Axelar team, and you can always reach out to me on the Moonbeam Discord as well. So yeah, thanks for having me.
Thanks for coming, Jeremy.
Awesome. Thanks, everybody.
All right.